This video will cover the synthesis of amines through direct alkylation. Direct alkylation involves an SN2 reaction of the amine as a nucleophile and an electrophile with a good leaving group. Reaction of the amine nucleophile with the electrophile produces a substituted amine. Remember that because this is an SN2 reaction, it will work best if the nucleophile is not too hindered and is therefore ammonia, a primary amine or a secondary amine, and if the electrophile is not too hindered. Therefore, if the R' group is a methyl or a primary substrate. Typically, for our electrophile, we also need a good leaving group, like chloride, bromide, iodide, or a tosylate. Notice that the product of this reaction is also an amine, and if we start with ammonia or a primary amine, our product will be a primary or secondary amine, which can also act as a nucleophile in this reaction. Therefore, we have to consider how we can prevent the product from reacting as a nucleophile with the electrophile. Let's consider this example. What if we wanted to make ethylamine using direct alkylation? To do this, we would need to use ammonia and an ethyl halide or tosylate. This would produce the ethylamine product. However, notice that this desired product is a primary amine, which is also capable of direct alkylation. It can therefore react with another molecule of the ethyl bromide to produce a secondary amine product. Notice that this undesired product is a secondary amine that can then react again with another molecule of ethyl bromide. So how do we prevent the products from reacting with the electrophile instead of the desired reactant ammonia? The solution is to add a very large excess of the amine compared with the ethyl bromide. By using a lot more ammonia than ethyl bromide, it's much more likely that the ethyl bromide will bump into an ammonia molecule rather than the product ethylamine or the other product diethylamine.